A single lightning bolt can get hotter than the surface of the sun, and most of us have stood closer to that power than we realize. Picture a late summer afternoon. The air feels heavy. The sky turns a bruised purple-gray. You smell rain before it arrives, that sharp, clean scent people notice right before a storm breaks. Then the first flash lights the clouds from the inside, and a few seconds later the thunder arrives like a door slammed somewhere in the sky. In that moment, you are watching one of Earth's most extreme natural events. A typical lightning bolt can heat the air around it to about 30,000 degrees Celsius. That is roughly 5 times hotter than the visible surface of the sun. The sun's photosphere sits near 6,000 degrees Celsius. Lightning briefly outruns that number in a channel only a few centimeters wide. How is that even possible? Lightning is not fire in the everyday sense. It is a giant electrical discharge. Storm clouds separate charge as ice particles collide and churn. When the difference in charge becomes huge, the atmosphere can no longer hold it back. A leader channel races downward, a return stroke surges upward, and in a fraction of a second an enormous current floods through a narrow path of air. That sudden current rips electrons from atoms and turns the air into plasma, a superheated state of matter that glows white-hot and expands faster than sound. The expansion is what we hear as thunder. Light reaches you almost instantly. Sound crawls by comparison. That is why you can count the seconds between flash and boom to estimate distance, about 3 seconds per kilometer or 5 seconds per mile. Here is a real-life moment many people recognize. You are driving home as rain needles the windshield. Streetlights flicker. A bolt hits somewhere nearby and the whole street seems to photograph itself in white. For half a second everything is sharper than daylight. Then the thunder hits your chest, not just your ears. Your car radio crackles. Somewhere a transformer pops. That physical jolt is the shockwave from air expanding around a plasma channel hotter than starlight. Another everyday experience, standing under a metal roof or waiting at an airport gate while a storm grounds flights. Ground crews pause. Planes wait. It can feel like an inconvenience, but those delays exist because lightning can strike aircraft, runways, and power systems with currents measured in tens of thousands of amps. Modern planes are designed to handle strikes, yet caution still rules the ground. Lightning also leaves quieter fingerprints. When a bolt hits dry sand, the heat can fuse silica into glassy tubes called fulgurites, fragile sculptures of a storm frozen into the ground. Most of us never dig one up, but the same physics is happening overhead during an ordinary thunderstorm. Not every flash is the same. Cloud-to-ground lightning is the dramatic dagger people photograph. Intracloud lightning is more common and lights the storm from within. A single thunderstorm can fire many strikes in minutes. Earth as a whole is struck millions of times per day. That sounds impossible until you remember how much of the planet is covered by unsettled weather at any given hour. There is also a human-scale lesson inside the spectacle. If your hair ever feels like it is lifting on a ridgeline or open field during a storm, that is not a quirky breeze. It can be a warning that the electric field is rising and a strike may be near. The safe move is simple and unromantic. Get inside a sturdy building or a hard-topped vehicle, away from trees, poles, and open water. Wait 30 minutes after the last thunder before heading back out. And then there are the quieter storms, the ones you watch from a porch or a campsite when the rain has not reached you yet. The horizon keeps flashing, almost like a faulty streetlight, and you hear only a soft rumble or nothing at all. People call that heat lightning, but it is usually ordinary lightning too far away for the thunder to survive the trip. Sound fades with distance and gets scattered by air and terrain. Light does not give up so easily. That gap between what you see and what you hear is another everyday reminder that storms are operating on physics, not mood. Kids often learn the flash-to-bang count on nights like that, standing in a doorway in pajamas, arguing over whether the storm is close or still far. Those small family scenes are built on the same numbers scientists use: the speed of light, the speed of sound, and a channel of air briefly hotter than the sun. So the next time a storm turns the sky into a strobe light, remember what you are really seeing. Not just rain and noise. A brief river of plasma. a temperature that outruns the sun's surface, a shockwave riding thunder across the landscape, and a reminder that extreme physics is not only in outer space. Sometimes it walks right through your afternoon and knocks on the windows. Follow for more amazing facts.